All right, we're going to talk about how to find the inverse of a 2 by 2 matrix. And it turns out it's a fairly simple procedure for finding the inverse when you just have a 2 by 2 matrix. It's much more complicated if you have a 3 by 3 or 4 by 4, but with 2 by 2 it's not so bad. So let's suppose A is this 2 by 2 matrix. So the entries we'll think of as being A, B, C, and D. So A, B, C, and D are just numbers. Okay, and it turns out that A inverse is, well, this is going to be a constant here, AD minus BC. Okay, 1 over that's going to be a constant times this matrix. Now notice, what is this matrix? Well, it's the matrix that you get from the original matrix by flipping the A and the D, right? So notice it's D up here now and A down there, and taking negatives of the B and the C. Okay, so to find the inverse, you flip the A and D, take negatives of the B and C, and then you multiply out front by a constant. Now the one thing you need to have is you don't want AD minus BC to equal 0, right? Otherwise this won't be a constant. 1 over 0 is not defined. And that number AD minus BC is called the determinant of that matrix A. Okay, so a matrix is going to have an inverse if and only if that determinant is non-zero. Okay, so a matrix will be invertible if the determinant is non-zero. And again, we're just looking at 2 by 2 matrices in this example. Okay, so for determine if A has an inverse, and if so, find it. Okay, so notice here's our matrix A. We see our entries A, B, C, and D. Okay, A inverse, what is A inverse going to be? Well, first of all, let's look at the determinant. What is the determinant of this? Well, it'd be 4 times 1, right? 4 times 1 minus 2 times negative 3. Okay, so what you really have is 4 plus 6, which is 10. Okay, so since 10 is not equal to 0, this matrix A is invertible, right? We did 4 times 1 minus 2 times 3. Okay, so what we get, our inverse matrix is going to be 1 over that determinant, right? 1 over AD minus BC, and then times, well, the matrix that we get by flipping these two numbers, the 1 and the 4 are going to flip, right? The A and D, the flip. And then we take negatives of these two numbers, okay, the B and the C. So we're going to have a negative 2 and we're going to have a positive 3 right here. Okay, so this is A inverse. Now notice, A inverse though, when you multiply a scalar times a matrix, that's just like multiplying each of the entries in the matrix by that scalar. So this is a scalar multiplication. So if we were to write out what the matrix actually is, we have to do 1/10 times each of these entries. So this would be 1/10, this would be negative 2/10, this would be 3/10, and this would be 4/10. Okay, now you could simplify these, so minus 2/10 is really negative 1/5, 4/10 is really 2/5, but it turns out this is the matrix A inverse. Now how could you check your answer? Well, just multiply A times A inverse and you should end up with the identity matrix. Okay, so I'm not going to do that in this video, but you can check it for yourself. If you multiply this times this matrix, you get the identity matrix. Okay, let's do one more example. What is the determinant of this matrix A? Well, we get AD minus BC, so AD would be 6 times 3, okay, minus BC, that would be 2 times 9. So what we get is 18 minus 18, which is 0. So the determinant of this matrix is 0. So this is not invertible. Okay, A is not invertible. It does not have an inverse. So you can try all you want to find another matrix. You can try all you want to find another matrix right here so that when you multiply it, you get this matrix, the identity, but you can't do it. Okay, there's no matrix that you can find here where this times that matrix gives you the identity. Okay, it's not invertible.